This is trigonometry, section 4.4. So today we're going to talk about trigonometry and calculating all these different functions at any angle. And I think at this point we really have all of the skills necessary to answer these questions. I'm just going to show you some alternative ways to answer them. One of the things that you will need to know for your test is how to use reference angles. And even if you don't necessarily use reference angles, if you just kind of do it the way that we've been showing, where you're either using special right triangles, any kind of right triangle trigonometry, your unit circle, this is just an alternative method that you can use. I think it's not necessarily every student's favorite, but I do understand the value of at least showing and kind of solidifying a lot of the different things that we've seen so far. So really, I think this is kind of a good wrap-up section, our last section before our tests. So remember, right, we have our trigonometric functions. We can define them by using x and y as if we were to kind of draw a right triangle on the coordinate plane. But for the most part, I definitely recommend using the SOHCAHTOA, using opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But if we did want to use kind of the idea where we have a triangle, right? We have our triangle here that we can set up and we can figure out all these things. You can also do that as well. We always want to make sure, right, sometimes we may get undefined answers, like the tangent of 90 degrees is undefined, for example, and that's okay, right? It's okay to have undefined answers. So we're going to bring us back to one of the questions. This was actually in our pre-review for the unit, if you remember back to that lecture. I kind of also asked you to complete one of these questions probably on your own, or if not, maybe hopefully you can. But this is kind of the nice thing, is we've learned so many things at this point that we're now wrapping up with kind of what we would consider one of the hardest questions that was on that pre-review. So kind of even just getting us started for this unit. And it starts out like this. This is kind of how these questions are asked. So let negative 3, 4 be a point on the terminal side of theta. So here's our angle theta here. Find the sine, cosine, and tangent of our angle theta. So even though, right, this is our theta angle, our right triangle that we're going to draw to the x-axis is on this side. So that means we're going to use what is called the reference angle. And your book likes to denote it with this little apostrophe at the end. It kind of says, you know, these two angles are related, right? They're supplementary angles. And I can still use kind of our understanding that we're going to just go with what we have in this quadrant here, in quadrant 2. So if negative 3, 4 is my coordinate point, then that tells me, right, my x value down here is negative 3, and my y value up here is 4. And so the book says, okay, let's find sine of our angle theta. Now, if you look at our definition above that we had a few pages before here, so I know you've got that out in front of you, sine of theta is y divided by my radius. Well, the radius here is this r value, which we have to calculate using the Pythagorean theorem, but thankfully, right, because this is a 3, 4, 5, we don't have to do much calculating, but if we needed to, we would use the Pythagorean theorem to find it. So our sine value is y divided by r, and so this is x down here, right? It's on our x-axis. This is y. It's over here on our y-axis. So I get 4 over 5. But the other way that you can always think of it, right? I'm not really introducing anything new, right? We could think of this as our opposite side, our adjacent side, and our hypotenuse. And we get the exact same answers, right? This is also equal to opposite over hypotenuse, which we know that's what our sine value uses. Our cosine value, if we look at the definitions above, we'll see that's x over r. Well, in this case, our x value is negative 3, and our r value is still 5, but it also represents, remember, cosine is just adjacent over hypotenuse. And our last one that we wanted to calculate was tangent of theta. Tangent is y over x. We need to make sure x is not 0. It's not. It's negative 3. So I get 4 over negative 3. But remember, it's also just opposite over adjacent. So if you'd prefer to just kind of use that right triangle trigonometry as opposed to, kind of memorizing these equations, I encourage you to do so. With any trigonometry question, there are about at least 2 ways to solve them, if not more. So notice though, cosine was negative in this quadrant. Tangent was negative in this quadrant. So if you can remember back to what we learned last semester, there's kind of a rule for this, right? How do we remember where, in what quadrants things are positive and things are negative? So last year what I introduced is an acronym. All students take classes. Whether you want to come up with one that's more fun than that, it's all up to you. But this tells us that in quadrant 1, everything is positive, including cosecant, secant, and cotangent. If sine is positive in a quadrant, so is cosecant. Remember, these are partners together, so whatever is true for one is true for the other in terms of positive, negative. In this quadrant, sine, that's why the S is highlighted, sine is the one that's positive, and remember that then adheres to also cosecant being positive. Down here, tangent is positive, so is cotangent, whereas all the other ones are negative. And then in this last one, cosine is positive, and so is secant, all the others being negative. So if you kind of remember that all students take classes, you'll at least remember all sine, tangent, cosine. And once you have those, you can kind of remember those partners, like sine with cosecant, tan with cotangent, and then cosine with secant. So let's look at a little bit more of an advanced question, taking it up a notch. So we know the tangent of some angle that's on our coordinate plane is negative 5/4. And so that tells me that tangent is negative, and then they tell me that cosine is greater than 0, meaning cosine is positive. So in which quadrant on our unit circle, right? Remember, we've got all students take classes. In which one is cosine positive but tangent negative? Quadrant 4. So this tells me wherever this angle is when I draw it, and I'm going to draw it because I really think that helps out a lot. I'm going to draw it from within quadrant 4. So I'm going to go ahead and draw an angle, and then from there, right, I'm going to create my right triangle. Here's my angle, right? Your angle is always, I've got a point out here. I don't know what that point is. They didn't give it to me, but I know that the angle that is formed with the x-axis is my primary angle. That's the angle that I want to focus on. That's where I'm going to label my theta. So I know this over here is my opposite. This is my adjacent side. And this is my hypotenuse. Now, if you prefer to use those equations, right, y over r, x over r, those things you can. I'm going to go with the whole opposite adjacent hypotenuse because I know that's really what we practiced a lot last year, and I want to kind of stick with something that I know we can calculate. So if I know tangent, right, is opposite over adjacent, I have 5 and I have 4. Now, one of these is negative. Is it the x coordinate or the y coordinate? Think in terms of this quadrant, the negative is going to be attached to the 5, right? We are at 4, so that tells me this point down here, we're going to be at 4, negative 5. So I just keep building more and more knowledge so I can figure all this out. Now my hypotenuse I do not have. So in order to find it, I'm going to have to do the good old Pythagorean theorem. And because I'm trying to find the hypotenuse, right, that's your C value. So I get 16 plus 25. So I get 41. That tells me that the square root of 41, there's no perfect square that goes in there. That is my hypotenuse. The question is asking for us to find the sine value. So thankfully, we've got all the information that we need. So the sine of theta is opposite over hypotenuse. And yep, we got to take care of that. There we go. And it's also asking us to find the secant of theta. So remember, Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. Remember, we take the reciprocal there. So I get the square root of 41 over 4. And remember, we kind of want to make sure that this makes sense, right? In this quadrant here, cosine and secant are positive. We got a positive answer over here. Perfect. Down here, we know sine is negative there. There we go. Now, there may be some questions on your homework where they want you to find an approximation. It just depends on the question. I think we know at this point how to plug these into our calculator and get decimal answers. Okay, example 3 wants us to evaluate the cosine and tangent functions of these kind of main angles here, right, that are on our unit circle. So if you have a unit circle out, I recommend getting it. It's kind of a nice reference to have here. We got 3 pi over 2, right? My coordinate points here, I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So if I want to find the cosine of, say, let's go through these one at a time. We'll do 0 first. Remember, it's just the x-coordinate, 1. Cosine of pi over 2, 0. Cosine of pi, negative 1. And then the cosine of 3 pi over 2, that's 0 as well. Now let's find the tangent values. The tangent of values are sine divided by cosine, which is 0. The tangent of pi over 2, sine divided by cosine, is undefined. The tangent of pi, sine divided by cosine, is 0. And then the tangent of 3 pi over 2 is, again, sine divided by cosine. We get another undefined. So let's talk a little bit more about these reference angles. I know I previously mentioned it in that first example, but what really are they? So the book really wants you to start thinking of reference angles as another way to solve these things, as a way, if we can just find this acute angle. So when we talk about an acute angle, it has to be less than 90 degrees or less than pi over 2. If we can just refer to that, then I really only need to worry about quadrant 1, right? I can worry about everything here. Everything could be found just by using quadrant 1 if everything is an acute angle. And then from there, all I need to memorize is just that all students take classes, and I can just attach a negative sign to it if it happens to be in a quadrant where that trig function happens to be negative. So how do we find these reference angles? It always is your distance to the x-axis. And I say distance because it is always positive. Always positive. Remember, we're trying to find an acute angle that'll live in quadrant 1, so it needs to be a positive angle between 0 and 90 degrees. So if I'm here in quadrant 2, I just find the distance to the x-axis, and I refer to it, remember, our reference angle, we put that little dash at the end. If I'm in quadrant 3, I just find the distance up to the x-axis. If I'm in quadrant 4, I find the distance up. So when I'm on this side of my coordinate plane, I'm thinking, how far away from 180 degrees am I? When I'm on the right side of my coordinate plane, I'm thinking, how far away am I from 0 or 360 degrees? It just depends. So let's do some examples, and hopefully as we find some examples, that'll help us out. So first is 300 degrees. So 300 degrees I know is down here. So that tells me it's in quadrant 4. I just want to figure out how far away is it from the x-axis. Well, the closest is 360. So the difference is just 60 degrees. That is my reference angle. Let's do another one that's in degrees. So I've got negative 135 degrees, right? So if it's negative, I'm going to be going this way, which means it's down here in quadrant 3. And I just want to figure out, okay, how far away is it from here? You have a couple of different choices. You can just kind of think about it, right? 180 to 135, that's 45 degrees. It's just 45 degrees. But if kind of this negative value is tricking you up, remember, you can always add 360 to this. You can find a coterminal angle. So that's 225. So that would be us kind of going around the other way. Remember, we're still going to be the exact same terminal side of this angle, but how far away is 225 from 180 degrees? Well, it's 45 degrees. So either way that you think of it, you're 45 degrees away from the x-axis. Now let's talk about 2 pi over 3, right? 2 pi over 3, we got to think about, okay, where is that on my unit circle? So we've got 2/3 of a pi. So the way that I think of it like a fraction, right? I know that it's a pi, right? We're trying to get to pi. How far away am I from pi? In order to do that, I just think, well, I know here it's 3 pi over 3. So I'm just going to be pi over 3 away from that reference angle. And I'm hoping that's what you have in your notes rather than 2.3. I'm seeing something different on my note packet. But anyways, I think it's a little bit harder to work with, here, I'm actually draw it. It's a little bit harder to work with radians, but really you just think of it, how far away am I from the x-axis? So either I'm going to be to pi or I'm going to be over here to 2 pi. So you just got to figure out which one is it that I'm looking for. In your notes, you may have one other example, or it might be worth doing one more example, and that's 3 pi over 4. So try 3 pi over 4, right? 3 pi over 4 is very similar to 2 pi over 3. How far away am I from pi? Well, I'm simply 1/4 of a pi away. All right, so in the real world, right, we have a lot more angles than just these 30, 45, 60, 90. So there will be times where we have to find the values of these trigonometric functions for things that aren't on our unit circle. But with that said, if we do have values that are outside of our unit circle, we usually will be approximating. And so you can still use this so here's kind of your book's approach here. You can still determine the function value of the reference angle, and then depending on the quadrant, just put this is what a fix means, just put the appropriate sign in front, if it should be positive or if it should be negative. I highly encourage you to kind of memorize all these major angles if you haven't by now. Remember, on the test, you'll have to fill out your unit circle. There is a Quizlet available linked on Google Classroom if you want to practice these with some flashcards. But there they are, right? Here's some of the most important ones. We've got our degrees, we got our radian, sine, cosine, tangent. This doesn't include secant, cosecant, or cotangent, but you could definitely add this kind of to your table of values. So we're going to go through an example, 3 examples here, where we're going to use reference angles. Like I said, if you do not like this approach, it is okay. All I want to do is a big thing about being a math teacher is everybody thinks, I'm going to make students do it one way. That's not the case. I want you to pick a way that makes the most sense to you. Because honestly, if somebody asked me, what's the cosine of 4 pi over 3? I would just pick up my unit circle, look at it, and tell them what the cosine of 4 pi over 3 is. But let's do it using reference angles. I want to figure out what is my distance to pi for 4 pi over 3. Well, my reference angle, I'm 4 pi over 3, so that tells me, right, I'm over here in this quadrant. How far away am I from pi, which we can also think of as 3 pi over 3? Well, I'm 1/3 of a pi away. So my reference angle is pi over 3. So let's look on our, let's think about what's the cosine of pi over 3, right? Hopefully you have it memorized from our table on the previous page. It is just 1/2. But I want to figure out the cosine of 4 pi over 3. Well, in this quadrant here, is cosine positive or negative? It's negative. Therefore, this is negative 1/2. I'm going to make sure I put the negative there. You can see it. All right, let's look at our next one. The tangent of negative 210. Well, let's figure out, I want to add 360. This is the same thing as the tangent of 150 degrees. So what is my reference angle for 150 degrees? Let's go ahead and draw it. Here's 150. How far away is it from 180 degrees? Well, it is 30 degrees away. So what is the tangent of 30 degrees? The tangent of 30 degrees is square root of 3 over 3. Right? So let's consider we have that memorized. But in this quadrant here, tangent is going to be negative. So therefore, if I want to finish out the question, I'm going to say the tangent of negative 210 degrees is equal to negative square root of 3 over 3. All right, last but not least, let's look at cosecant of 11 pi over 4. So let's figure out where's 11 pi over 4, right? That's kind of a big number there. Maybe we want to subtract 2 pi first. So I want to find the cosecant of 3 pi over 4. Okay, so 3 pi over 4, that tells me we're going to be up here. Right? And I want to say, okay, how far away am I from pi? Well, that tells me my reference angle is going to be pi over 4. Right? Like if I'm 3/4 of a pi here and I'm trying to get to 4/4 of a pi here, I'm just 1/4 of a pi away. Well, I know cosecant's not on our sheet there, but what is the sine of pi over 4? Do we have that memorized? Hopefully we do, right? It's a square root of 2 over 2. And I want to find the cosecant. So in order to find the cosecant, I'm going to have to first ask myself, is it positive or negative? I'm in quadrant 2. In quadrant 2, sine and cosecant are positive. So I don't have to change the sign, but I do have to get rid of that square root in the denominator after I find the reciprocal, which means the cosecant of pi over 4, which is going to be the same as 11 pi over 4, is the square root of 2. So that's what I said. This is a different approach. It's by using reference angles. You can kind of use whatever approach you find to be the quickest or the one that makes the most sense to you. Sometimes students really just want to only work with positive and at the very end attach a negative. And this is a good approach to be able to do that. All right, our last couple of examples are just kind of us, reviewing a couple of things from the unit. So let's remember that we do have some of these trigonometric identities. Remember, I will give you those on the test so you don't have to memorize them. If I know the sine and I want to find the cosine, let's think of, and it's the most important one, let's think of an identity that uses both sine and cosine. The one that I'm thinking of is sine squared theta plus cosine squared theta equals 1. I know that my sine value is 1/3, but I don't know what my cosine value is. So I'm going to use some algebra to go ahead and solve it. So this tells me cosine squared theta is 8/9, right? I'm going to subtract 1/9 from both sides, and then I'm going to take the square root. I wind up with the square root of 8 over the square root of 9. I can simplify this down. This is 2 square root of 2, and I can simplify down the square root of 9, which is 3. So I get 2 square root of 2 over 3. Now let's look back at the question again. It tells me that we're in quadrant 2. In quadrant 2, we know sine is positive. What about cosine? Cosine is negative. So I have to go ahead and attach a negative to it at the very end. So before when we were studying trigonometric identities, we didn't worry about what quadrant the angle was in. Now, this is a perfect example of how you're going to have to go back and determine, okay, I've already solved the problem. Now do I need to attach a negative to it or not? Now that we know our sine and our cosine, let's find tangent. Remember, tangent is just sine divided by cosine. I'm going to write this all out so we can see it. I have 1/3 divided by negative 2 square root of 2 over 3. So I get negative 1 over 2 square root of 2. Gotta keep going. So I get negative square root of 2 over 4. And in this quadrant, right, in quadrant 2, we do want our tangent value to be negative, so that makes sense that we would get out a negative answer. Example 7 has you using your calculator just to make sure we remember how to do these. For cotangent of 410 degrees, we want to make sure we're in degree mode. And because it's cotangent, I need to plug in the tangent of 410 and then put in that negative 1 sign. You should get out about 0.839. Now, the sine of -7. Notice how I don't have a degree symbol. If you don't see a degree symbol, you need to assume that you are in radian mode. So change your calculator to radian mode. And then you just type in sine of -7 just as is. You should get out negative 0.657. Secant, I see a pi there. I also don't see any degrees there. So we're in radian mode. So I want to find the inverse. So I have to type in cosine. Make sure you use the pi button on your calculator and then the inverse button to get the reciprocal. Sorry, I should be calling it the reciprocal button, not the inverse button. I get 1.064. So I think these are just kind of having us wrap up and remember all of these different things that we need to be able to also use the calculator to do, especially in different application problems. All right, our last example of the day is a tricky one. It's a tricky one, but it's only tricky in that I'm sure if you take the time to stop and read this, you'll say, "Whew, this is challenging to do." So let me kind of walk you through my recommendation on how to solve something like this. So the terminal side theta lies on the given line in the specified quadrant. Find the exact values of the trigonometric function of theta by finding a point on the line. Okay, the first thing I do, I draw my coordinate plane. I draw my line. We have y equals -x. So here's where, remember, in Algebra 1 and Geometry and Algebra 2, we made you be able to plot lines. This is a very calculus-y type question. This is very calculus-y, okay? I need to just know these things off the top of my head. I need to know how to graph this line. It has a slope of -1 and it goes through the origin. So here's my line to the best that I can do on my drawing tablet here. I know, right, that the angle that I have here is my theta. I'm going to use my reference angle over here and my right triangle, understanding, because we're in quadrant 2, so I need to be in quadrant 2 here. Now it says, find a point that is on the line. I recommend picking the easiest point possible, and the point that I'm going to pick is -1, 1. So let's say this point right up here is -1, 1. I know down here is -1. Oh, sorry, I want to make sure that we know, right? Our theta, our reference angle is the angle within here. This is my right angle here. So this is -1, this is +1. This is one of our special right triangles, right? My hypotenuse is the square root of 2. Since this is my major angle here, my angle that I'm referring to, I want to label my opposite, my adjacent, and my hypotenuse. You can kind of see, right? It's forming a 45-degree angle. So all these answers that we're going to get are those that refer to a 45-degree angle. Let's go ahead and calculate, right, the sine of theta. Opposite over hypotenuse. This is just assumed at this point, right? Cosine is adjacent over hypotenuse. Notice that's going to make it a negative value. If I want to find, right, the secant, all I have to do is I'm going to flip it. I'm going to flip it a little bit earlier. I'm going to do it right here. So it'd be negative square root of 2. And my cosecant would be positive square root of 2. My tangent value, right, opposite over adjacent, -1. My cotangent value, opposite over adjacent. And that makes sense, right? In this quadrant, sine and cosecant are the only two that are positive, and so there we have been able to successfully find all 6 trigonometric functions. But pick a point on the line that is easy to work with. That is what I recommend you do. All right, thank you for your time. This ends this particular unit.